Right. Okay, for our last illustration or question on inclined planes, and this is another rough inclined plane problem. We've got a particle of mass 5 kilograms sitting on a rough inclined plane as shown in the diagram below. We don't know what the angle of the plane is, but so it's just marked as theta. The angle theta between the plane and the horizontal is now increased. So they're saying that this angle is gradually being increased till it's reached this position, and when it's reached this position, it's at the point where the particle is just about to slide down the slope. Now that's very important. It's just on the point of sliding down the slope. That means that we know that the coefficient of friction is just on the point on its maximum value. Now, as I've said several times now, if it's trying to move down the slope, the frictional force will be opposing it and it will be up the slope. And the size of the frictional force will be mu times the normal reaction force with the plane. So we have to put the normal reaction force in first, R, and then we know that this force will be mu R. Now the weight is 5 kilograms, it acts down. I'm going to put it in dotted this time because this is going to be the weight force acting down. I'll put it in dotted like this, and it's going to be 5g. The reason for that is that I'm going to now replace this by its two components down the slope, which is a real force acting down the slope of 5g sine theta and I replace the component of the weight into the plane is going to be 5g cos theta. So all of the solid lines represent the forces that I've got to now use in my calculation to balance things out. Right, so first of all I'm going to consider the forces perpendicular to the plane, and I'm going to take the upward direction as positive, so I'm going to write R in the upward direction like that. That's resolving the forces in the perpendicular to the plane. I get R, the reaction force, minus 5g cos theta equals 0. It equals 0 because this particle doesn't move away or into the plane. It always stays on the plane. So therefore, it's only going to be in this direction where there's going to be a tendency or an actual motion of the particle. In this case, it's only going to be a tendency because it's just on the point of moving when we reach this point. So that's our first. Now immediately you can see from this that we can't solve for R like we did in the previous questions because we don't know what theta is. So we're going to have to just say from this that from this we can say that R equals 5g cos theta and leave it at that. We'll come back to use it. We'll use that in a moment. Okay, now we're going to consider the forces down the plane. So I'm going to take the direction down the plane as positive. So I'm resolving the forces down the plane. Positive direction is that. So I've got 5g sine theta minus mu r, because mu r is acting in the opposite direction, equals 0. And sometimes it's good because there's no motion down the plane, no acceleration down the plane. I like to I like to let the examiner know what I'm doing, so I'm telling him that I know that there's no motion down the plane, so there's no acceleration, therefore that's equal to 0. Right, now we know that the coefficient of friction is 0.4, and therefore, and by the way, this is part B of the question. Part A was to draw all the forces, so we've done part A up there. Now part B, we now can plug in 0.4, and we know that R is given by this expression here from 1. So I'm going to put those into my equation. So I've now got 5g sine theta minus 0.4 times 5g cos theta, because I'm replacing R by 5g cos theta. And that's equal to 0. And basically what I did is I've sub R from equation 1. Just let the examiner know what I'm doing. I'm substituting the value of R from equation 1. Right, so I get 5g sine theta minus, and 5 times 4 is 20, so it's 2g cos theta equals 0. And I can take the 2g cos theta over the equal sign, and I get that I get 5g sine theta equals 2g cos theta. Okay, I've got g on both sides, so let's cancel those out. And now I need to solve this trigonometric equation. And this is a nice and simple one, because if I divide through, well, first of all, I'm going to divide both sides by 5. So I end up with sine theta equals 2 over 5 cos theta. And then I'm going to divide both sides by cos theta, so I end up with sine theta, move it up a little bit, so I end up with sine theta divided by cos theta, which we know is tan theta, equals 2 over 5. Okay, if tan theta is 2 over 5, therefore theta must be the inverse tan of 2 over 5, which is or 0.4. And if I put that into my calculator and put in, so we want to shift 10 to the minus 1 of 0.4 equals 21.8. And I've just double checked that I'm in degrees. Yep, I'm in degrees, so it's 21.8 degrees. So therefore theta is 21.8 degrees. Okay, so that's the end of the last of these questions.